Hello everyone, welcome to this talk. Today we're going to talk about taming horses for combat. I'm Sina, I'm currently working in MDSec. A quick, even more quick introduction about me. Application security engineer at MDSec, part of the exploit development group which we have. And also I work with Microsoft from here and you can follow me on Twitter at Synology if you had any questions or you wanted to do any collaboration on certain projects. So first we're going to talk about what are memory horses and that if it can ride them or not, different type of memory horses, and first of all we're going to even talk about like what's the definition, and then we're going to take a look at creating memory horses in Tomcat, ASP.NET, and Flask in Python. This is mostly a technique. It's not limited to any frameworks or technologies. It's just a technique again. And then we're going to talk about a little bit about the detection. So what are memory horses? The concept of a memory horse is basically a web shell, but which resides in the memory. This will be happening by exploiting the concept of having multiple components during the runtime when you have a framework. For example, when you're using Tomcat or a Spring, you have some components which are inside the JVM when the application starts, and whenever you make a change to the code, you need to restart your container, restart your web server. So that means there are some objects that get registered during the runtime and reside in the runtime. By using the memory horse technique or web shells, you can basically register your malicious components during the runtime of the application by using a vulnerability such as say deserialization or Codeinjection, and with that you can have a malicious component registered in the application without touching the disk. The reason that we need these memory horses is because not a lot of adversaries, red teamers, offensive guys basically don't use them because they're a little bit difficult to craft. Interestingly, in the Chinese and the Eastern market of offensive researchers, they heavily use this technique, but it's quite funny that it's not being that well known currently in the main market maybe. And they're not heavily signatured like the rest of the techniques which we have, like uploading a JSP or a PHP or ASPX. This is basically injecting code during the memory using a web vulnerability. How do we craft these and how do we basically inject them in an application? As I said, using different kind of exploitation techniques, such as, for example, deserialization, template injection, SPL injection, or GNL exploitation, or any kind of other server-side code injection. You can inject a malicious component based on the framework which you're exploiting. The technique of memory horses was first discovered and researched by Landgrave back in 2016, but it wasn't, the research wasn't continued, and also it didn't cover other type of frameworks. It only covered Java a little bit, but didn't go after .NET and Python frameworks. So far, these are the memory horses or web shells which I've worked on to try to create a POC for them, which hopefully will be released in MDSec GitHub. For Java, if you're exploiting something like a Tomcat, you have exploitation of a servlet API. You can register your malicious filter, servlet, or a listener. When it comes to a Spring, we have two other components, a little bit different, but kind of same concept, but with different names, interceptor and controller. It can be more advanced when it comes to exploiting the memory horses, which you can use Java instrumentation, inject the Java agent during the runtime, but that is a bit difficult. And when it comes to .NET, we have filter routes, HTTP listeners, virtual paths, and with Python, I couldn't find the name, so I just put Flask. First, we're going to take a look at Tomcat and how memory horses work in Tomcat. If you can understand Tomcat, because this one is the most difficult one, you can basically understand the technique itself, and then you can use the technique in any kind of other frameworks, because Tomcat goes very in detail. So what's the requirement of basically a memory horse for Tomcat? back in the day, we had servlet version 1, version 2, and now we have currently we're saying version 4 as the latest one. Which servlets are a technology in Java, for those of you who don't know, and they're required for creating memory horses. Before version 3, it was not possible to dynamically register components during the runtime of the application. You could only define your components when you were creating your Tomcat application. So, but afterwards, and version 3 forward, it was possible to dynamically create components. So that's the requirement. You need servlet version 3. And servlet version 3 was introduced in Tomcat 7 forward, which most of the applications are currently at least Tomcat 7. If they're not, they have other vulnerabilities to be worried about. So basically, this is a life of a request. You have a browser, you have a client. That client will send a request to a Tomcat application. The Tomcat application have 3 main components as listeners, filter chains, and servlets. When you send it to a Tomcat container, a Catalina container, first, the listener will receive the request, tries to process it, and then pass it along to the filters chain. And then the filters chain pass it to the servlet. And then after they're all done with the request, they will try to return the response, and all of them can post-process the response. For those of you who want to know what are these actually in real life, so people mostly use, for example, filters in Java application and Spring applications to check, whenever somebody access /admin /star, which means everything, beginning with admin, just check if they have the right authentication cookie. And servlets are basically the code that gets actually executed when you're working with a Java application. And listeners, let's not talk about it for now. So this is very briefly a architecture of a Tomcat application. You have some connectors saying, I'm listening for port 8080, 443, or AJP connection, and everything else. And each server has multiple services. Each services has multiple engines. The most common one will be Catalina. And then after that, we have multiple hosts. We can have I don't know, a local host, admin, different things, and they can even be subdomains. And each host has the actual application, which is called a context. So the context has the code, has everything, has that root.war file that you see, or that Java files, which are running in a Tomcat container. This is just exactly what I just told you, engine, host, context, and at least we have the wrapper. A wrapper is just another object sitting before a servlet, controlling a servlet, actually. These are just terminologies from the Tomcat architecture, which are required to know, even a little bit, don't worry if you didn't understand it fully, to know about this whole concept of memory horses. Again, this is the same thing, just sending a request to the Tomcat server, which has the multiple services and connectors. This is what actually happens with those host, engine, and context. You got different hosts, A.com, B.com, and each of these hosts can have more than one Java application, more than one root.war. And each of those war files get exploded or deployed at each different context. For example, this application, B.com, can have two contexts. One /, which runs a different Java application with a lot of codes and servlets and everything else. And /manager runs a different root.war, which is just like a packaged Java application. Again, wrapper is just controlling the servlet and does other things such as resource recycling and servlet initialization. I know it's a little bit just pointing things to each other, but it is actually like that. Before understanding it, you need to know all this. Listener is the first one in the chain, and then it goes to filter, and then it goes to servlet. The reason that I'm bringing this one again here is because you as an attacker or you as a red teamer, you need to know which one of these places, which one of these components you want to actually exploit or register your malicious code or register your shell code inside. Because, for example, if you inject your malicious code into a listener, it always gets executed faster than anything else. If you inject it into a filter, with maybe like half a second delay, and then the servlet is the last one, which you can inject your malicious code. Each one of those three components has a different method of, again, injecting, because this Java memory horse is all about reflection, all about traversing objects to objects, going to the upper level object, and then from that object, enumerating other objects, using reflection to access private visibilities of other objects and modifying them. So that's why we have all of these connections to each other. And even if you want to make sure if that's the correct order, if you start reverse engineering, I don't want to say reverse engineering like that hardcore, but just like opening the Tomcat, the standard content class file in IntelliJ and start reading through, you can see that the architecture literally says listeners first start, and then there's filters and forward. When a client makes a request to an application, the web server receives it, passes it to servlet containers, and then that servlet container will pass it to the corresponding servlet. When we have chains in an application, because in this talk we're going to show you in the Tomcat section how can you register a malicious filter. If there are filters, because an application can have multiple filters, a filter to check if a user is sending an XSRF token, another filter to check if the user has the correct session, another filter to do something else, and then another one to do something else. For example, there can be a filter checking the content type, saying, oh, if the client is sending the header accept to expect the, for example, application JSON, then return my data as an application JSON. So we can have multiple filters, and these filters will be living together happily using a filter chain, which they need to manage who is the next chain and who is the previous chain and everything else. So this is how you dynamically add a filter. In Tomcat, if you remember, there was a file which was open in the IntelliJ called a standard context. And in the Tomcat documentation, in the Tomcat architecture, it says we have a main component called standard context, which controls basically everything. If you want to add a malicious filter, you need to get a handle to this object, and then start creating a filter and some other filter informations which a filter needs, and then at the end add it to the list of filter definitions. I try to create a mind map of showing all those reflections which I said. We have a servlet context, which is if we see as the process of reflection as like a ladder which we're going up, the most near object to us is called the servlet context, and then we always have a handle to this. So by opening a handle to servlet context, which we have access to, we can start doing reflection to access application context, and then the most top context, which is called the standard context. This is the big guy here, and then it has access to filter configs and other things, and we're trying to inject into this collection, into this hash map. And why do we do all this reflection? Why not just, I don't know, because when we go to the ASP.NET part, you see it's way much easier. You can basically explain the .NET memory horse in 5 minutes, easy, that's it, done. Because in ASP.NET, all the visibilities of the properties and methods have been set to public and public static. It's so easy to just say, oh, I want this object, and then you have access to it. You don't need to do any reflection. But when it comes to Tomcat, the application, the standard context as you see, which was here, it has set the private visibility, so we cannot just open a handle to it. When I say open a handle, just initializing the object or using the keyword new or something like that. This is a way to actually, this is a reflection code used for getting that all the handle to, as you remember, I said at this ladder of reflection, the most near object to us is called the get servlet context, and then from the get servlet context, we can get to a standard context. These codes need to be written. These are very basic. If you do not understand what they are, you can, honestly, if you start learning Java reflection, they're very easy to learn. Like, it's not that difficult. It's like reflection 101 in Java. And then you need to create a filter. Tomcat documentation says, all the developers of Tomcat, all the developers of Java using Tomcat know, when you create a filter, when you're creating a component saying, oh, whenever somebody accesses /admin, I want something to happen. That something to happen gets defined in the do filter, because the filter interface in Java says you need to implement this filter, and then inside this filter we have a malicious code saying, oh, if you saw in the requests coming to this application, in that whole drawing saying the life of a request, if you saw a request coming which has the CMD parameter, just get that parameter, pass it to get runtime exec, and execute this code. basically how to run OS commands in Java with using runtime, get runtime. But so we created the filter, and then now we have an open handle to a standard context and everything. Now we need to register that register that filter in the list of already existing filters in the application, because we don't want to overwrite them. Because if we overwrite them, we're breaking the application. We want to be as selfie as we can, so we want to open the list of the hash list currently containing all the filter definitions and add our own malicious filter inside it. So this is how you do it. Using this reflection, using a full class name, accessing filter definitions in Tomcat, you can get the list of all the filters. And then the reason that we do all of this reflection was accessibilities were private. And then a filter says, do something whenever somebody accessed a path. That path / something or anything. So we set our malicious filter to say / anything. So any part of the application which got access, our malicious code is listening to receive the CMD parameter. And then at the end, we can add the malicious filter into the filter configs. Application config is generated by reflection and put into filter configs hash map, which is basically, maybe it would be equivalent to the collections in .NET, which contains the list of all the currently active filters. And here's a demo for Tomcat. So as you can see in this application, we have a Tomcat application running here, and if we try to access the application query string mdsec calc, it just doesn't do anything. And I try to refresh it a couple of times, just being paranoid. I just try to refresh it, nothing happens. And then I go to an endpoint called vulnerable, which is expecting a parameter called data, and it does deserialization. Common collections 1 chain is inside the class path, so passing the common collections to it will work. And now you can see we have another version of voice to serial having common collections, and instead of passing a calc, we pass a Tomcat horse, which is a customized version of voice to serial. Hopefully will be pushed, and then it creates the chain, puts it into a silicon, and then after that we're gonna base64 encode that silicon.txt file, because the server is expecting a serialized object in a base64 format. We copy it, and then we send it to the application using the /vulnerable endpoint in the data parameter. And then the chain gets executed. We get a 500 error expected with the deserialization most of the times. And then now if we try to access that calc, we get the calc again. So now we go to the ASP.NET and how to do this in ASP.NET. In ASP.NET, we have a MVC architecture, and we have a really important file called global ASAX, if I'm not pronouncing the name wrong. And then in the global ASAX file, documented by Microsoft, says whenever this file changes, the application restarts. This file can contain a couple of code which gets run first when the application starts. And inside this file, by default, when you create a ASP.NET Framework application with Visual Studio, inside the file, you get these 4 lines by default. Now, most people don't know why are they there. They don't touch it. That might be the best option. But while I was researching this area to find memory horses in .NET, I needed to dig deeper in these. And as you can see in the 3rd line, it says, at the 2nd line, it says, filter config, register global filters. So there is something called global filters, which are, again, the concept of filters in .NET. All the frameworks have the same concept, maybe different names, but in this case, again, these guys call it filters. And then it registers those list of filters. Now we need to dig deeper and see what those global filters are, and either we can add our own global filter using a code injection vulnerability. So going inside the register global filters, we can see it's expecting a type parameter of global filter collection. So it expects a collection, and then we'll get the collection passed to it, and then add that collection to the list of already existing filters. Going inside the filters, we can see that collection type is actually enumerable of expecting each member of that collection to be a filter. So by default, we have 4 types of filters in a .NET application. These 4 types of filters are very important because if you remember in Tomcat, we had filters, listeners, servlets. And we have only one type of filter, just a plain old filter. But in ASP.NET, a filter needs to have a type. We have an authorization filter, action filter, result filter, and an exception filter. An exception filter only gets triggered when an exception happens in an application. So you as a red teamer might be wondering that, oh, what I want to do is I want to inject my malicious code in a filter, but I will set the type of that filter as an exception. And I know in certain part of the application, I can cause an exception, maybe a division by 0, and then my malicious code gets executed. That's just for making this all a self-here. But the order that you see in here, authorization filter, is the filter that always gets executed first. So we're going to make a malicious filter of type authorization filter. And if you remember in Tomcat, we had the filter chains. Those filters needed to know who is the next one and everything. .NET says, I don't need that. Just whenever you're registering a filter, pass me a order number, which by default, all the orders start from -1. So the first filter in Tomcat, which is the default, the first filter in ASP.NET, which is the default filter, starts with the order number -1. The next one you create is 0, and the next one 1, 2, 3, 4, 5, 6. So when creating a malicious filter, you set the order to -2, so you will be the first filter getting executed. And this is inside the whole filter method, which accepts the order. And if there is no order set, it just uses -1. And then the next time it gets incremented. And this is a malicious filter written in .NET. What you're seeing is this is an ASPX page, but it's funny, if we upload this file, we are canceling the concept of saying, oh, this is a fileless attack. There is no uploading of files. This is just for demonstration, and then in the next video you can see we exploited in a template injection way. As you can see, it's way easier than all of those codes in Tomcat. You just create a class of filter, which the parent class is authorization filter, this is the interface. And then you need to override this function called unauthorization, which is the code which gets executed whenever this filter gets triggered. And it's looking for the CMD parameter, getting it, and then at the end, passing it to, where is it? Oh, a startup info, a start info, which is a way to new process, basically, to execute a OS command in .NET. And then after that class gets created, you come here in this part, and then you will say global filters. That's it. You don't need to do any reflection. It's just an expose global object. You can just say global filters, get me the filters, and add my filter into it, giving it -2, which overrides the order of all the existing filters and system filters. This is a demo for this, exploiting a Razor code injection in .NET. Let's see it. So we have an ASP.NET application here, and then there is a feedback form. The feedback form is vulnerable to a plain old Razor template injection. You send @ parentheses 7 times 7, you get 49. And then this time, if you visit mdsec calc, there is nothing there, nothing launches. But after we inject the horse, we get that parameter registered using our malicious filter. So here, again, I'm just sending it again for demonstration, saying it doesn't exist there. And next, I'm going to copy the exploit for it. Oh, sorry, I pressed a space, and for some reason it went to the end. I just do it again. It was here, yeah. Sorry. I'm sending it a couple of times, so see if it just doesn't open. And then we are going to copy the code. The code is this one, exactly the code that you saw in the previous pages, but putting into @ so Razor can understand it. We send the feedback form. It doesn't show anything, doesn't crash, so that means you got executed. And now if you go back to the mdsec calc filter, it's an authorization type filter, and the calc pops, that means our malicious filter got executed. And I just do it for one at a time because everybody likes calc. Let's go to the next one. Now here comes the Flask part. When it comes to Flask, it is way easier. Like, it just gets easier and easier. Just tell you, like, if you understand Tomcat, if you start practicing Tomcat, you can understand all of them. Because that's the most difficult one, using lots of reflection, requiring you to understand the whole concept completely. In Flask, in Python, we have the Flask to create a web app. And then whenever we want to create a route, this time we're creating a malicious route, we can use a decorator called @app.route and then give it our information and detail to create the route that we want. But under the hood, because we need the under the hood part, it uses something called add URL rule, and this will accept some information about a new route and will register it. So in our exploitation, we need to call this. This is the final exploit for the Python one. I'm just traversing a tree of objects using built-in eval and then going up and up in that ladder, just going to each one of those objects, seeing the properties, seeing the methods, tracing, seeing callbacks, seeing stack traces to understand how can I access it. And then I'm getting the URL4 globals, current app to access the application, add URL rule. I'm adding a malicious route called /shell, which is expecting a shell parameter and executing it. And this is a demo for Flask, template injection. So we have a Flask application vulnerable to template injection. 7 times 7 returns 49. And then if you /shell CMD, I changed the parameters to CMD and the exploit here because it was, I think, confusing to have two parameters and have same name. And here I will paste the code for what I just show you in the slides. Adding a malicious route, a /shell, which when visited, it will import os.popen, and it will access the CMD parameter and runs it. Okay, application says none, you'll execute it, and now if you visit this page again, we're going to see, again, calculator. So this was the end of the talk. Just one other topic which I want to mention. Alibaba team, again, as you remember at the first of this talk, I mentioned this research was done for Tomcat only back in 2016 and wasn't continued anymore. And back in the day, Alibaba team wrote an analyzer for a JVM analyzer for Java, which just injects a Java agent into a Tomcat application and it starts listing all the existing filters using the runtime. And using that tool, it's possible for an incident responder or someone to see them. That tool wasn't maintained anymore, and there are other more variants. If you start researching on this topic, you see there are other variants of malicious components which will not be detected even by that Alibaba tool. So if you search Alibaba JVM Object Explorer, you can find the tool, and that tool can help until some point to detect these malicious objects. Thank you very much. If anyone has questions, feel free to ask. Thank you. Yeah. Yes, a Spring and a Spring Boot works. Just with a Spring Boot and everything, what you just need to do is you need to use something called an interceptor and a controller, which are here. When it comes to Spring, just register a malicious controller or interceptor. It works. It's basically a technique, so it's not like a vulnerability, basically. It's just a technique that you can use by exploiting reflection, by injecting reflection. Yeah, that's it. Any other questions? Yes?
So for PHP,
it is possible to also use PHP. it's called the undead horse, I called it here. Basically in the PHP code, I didn't bring a sample here, but in PHP you can there are some system functions in PHP which are not very well known, but if you call them, they will prevent a file when a PHP file gets executed, even if you delete the file, it's still inside the memory, so it doesn't matter. And in the PHP version 8 onward, PHP also introduced PHP Reflection. We didn't used to have reflection in PHP, but now we have reflection. So again, using PHP Reflection, you can inject a malicious serialized PHP code inside PHP FPM, which gets run. I'm preparing a sample for that, and then that's also possible.
Does it depend on the
version of the PHP? No, not the configuration, but the version of PHP. The PHP version needs to be 8. Because
I understand in general that PHP is that the PHP process would execute.
And it's done, yeah. Exactly.
Whereas with Java, you constantly the server that loads Java applications.
Yeah, that's correct. In PHP, when there exists PHP FPM, PHP FPM has certain objects which you can modify, and since PHP FPM is always running, listening for PHP FPM connections, that's why it works. Yeah, so I think, the PHP FPM.
Well, that makes sense now, yeah.
Okay, yeah, no worries. Yep.
Let's say for the Java one, you use the kind of, is it like a deserialization exploit to kind of inject it in?
Yeah. So normally, when it comes to an application, people are sending the same serialized exploit again and again and again. The first time that I came across this problem was reading actually an article of a colleague of mine, Surush, which is sitting there. He was exploiting Exchange in an article called, I think, NSA meets proxy shell, using a technique of virtual paths, if I'm not mistaken, using he didn't do any research on a memory horse or anything. He just came up with this idea that we can register a virtual path, and then we just need to send one deserialized payload, and that's it. We don't need to send it anymore, and we also don't need to download any file on the server. We can just register a malicious virtual path. And this virtual path, since it's just part of the .NET MVC, the detection of it is more difficult, and it's not easy for the EDR systems to detect it. So you don't touch the disk, basically. Yeah. And you don't send the serialized request again and again. Any other questions? I don't think anyone has questions. Thank you for joining this talk. Yeah. Thank you.